So welcome to the next set of talks on the Tending Your Open Source Garden track. My name is Matt Craig. I'm one of the chairs for this session, and Myrtle Seth is the other chair. We'll ask at the end, if you have questions for a talk, come up to the table here, and we'll have the microphones ready to go. It's my pleasure to introduce Sanket Verma and Josh Moore, who are going to talk to us about the Zarr community. Let's give them a warm welcome.
Thanks. So yeah, and thanks to all of you for joining us to talk about the evolution of Zarr, its growth. So Zarr is this format for storing out of memory, so larger than memory arrays. This is really a story about taking something that grew in the SciPython community, and we're trying to now reach out to other communities and bridge multiple languages. So I am Josh Moore. I'm from the Zarr Steering Council. Sanket is I'm not supposed to look at him while he's taking a picture, is the community manager of Zarr, and I will pass over to him here in just a minute. I'll try to keep this short. I'm really just kind of setting the stage for what he's going to talk about. I will use the fact that I'm on the stage, though, to say we probably want to move away from Twitter and find a different place for our communities to grow in social media. I'm trying to do that on Mastodon. If other people have ideas, very happy to talk about that during breaks. So that's just something else we need to deal with, unfortunately. So what's my problem? By the way, this is the last slide that has the link to the slides if you want to go ahead and open those up and follow along now. I'm a research software engineer. I've been a RSE for longer than the term existed. I'm a member of the open microscopy environment, and what we do is try to build infrastructure for sharing large bioimaging data. We try to standardize formats and build software and server installations infrastructure for the community. Zarr is something we see as an opportunity to finally deal with the file formats problem. So my project has to deal with about 160 different file formats of images, and we think Zarr might be the path beyond this, so we're really excited. So what does these images look like? So this was probably one of the first projects I was involved with in the early 2000s. What they did in this mitocheck project was to knock out a gene and then watch a video of whether or not the cells died or divided, or did they speed up, or were there some form of mutation. But it was more than just this one image with a couple hundred cells in it. Each of these images was part of a large plate with hundreds of images, and there were hundreds of plates. So at the end of the day, it was 200,000 videos constituting about 25 terabytes of data. And I was expected in early 2000 to get all this online. I failed, and I also didn't get my PhD, right? So this just didn't work out whatsoever because we didn't have the infrastructure we needed. I did eventually get the data online in about 2016, but that's a different story. But if you're interested, I can tell you. And so this is where I got involved in the open microscopy environment and really said, okay, how can we go about doing this better so other PhD students don't have to suffer, right? So around 2012, I was working for the Journal of Cell Biology, or with the Journal of Cell Biology, to publish this data. An author came along and gave us this electron microscopy data of a zebrafish. At the time, this was the biggest image on the internet. At least that's what Wikipedia said. And so we were properly slash-dotted. We had 3,000 requests a second of people zooming in to see how cool this data was. It lived on one server alone, and it was a bear to keep it online. Today, that image is sitting, Google's slides is acting up. Go to the next slide. Is sitting on an S3 server somewhere in the Zarr format, and I don't have to host any infrastructure to make it accessible, right? You can go and you can look at these images, and I would make the proposition that you can't make it fail, right? So we've gone from somewhere where I had to work really hard and was awake all night for days to something where I don't think you can break it. And for me, as the person needing to provide all this, it's an amazing difference. It's really night and day. By the way, if you do go and click and play around, you're using a tool called Zarr from Trevor Mans, who's somewhere here at SciPy. He's a PhD student at Harvard Med School. He and his team, or his colleagues, built this. And yeah, you might want to buy him a Coke or a coffee or a beer or something else. Because yeah, it would be a great idea if we can keep people like this in the community. So I know there are more of them. Do what you can to keep people who build great things around, right? The thing is, though, that the data keeps getting worse. So about 5 or 6 years later, the data starts looking like this. Rather than being a one single color image, we now have 5 terabytes of multicolor single cell points of an entire mouse embryo now developing from the first cell to millions of cells. That data gets obviously much harder to share, and I thought someone was going to be here. He'll be here on Saturday. I'm currently being threatened with 10 petabytes of data for a single brain. And this is kind of the projection that's happening, and so as a community, we really need the right tools to make this stuff shareable. I don't think we're special in bioimaging, certainly in the geospatial domain, astronomy domain. There are data sets out there here for earth, wind, fire, even water, and other things already in Zarr, because each of the communities have the same problems. They have these huge arrays that they need to share, right? And Zarr is really kind of the easiest way to make this happen right now. So it chunks up the data, it lets you put it online, it uses all the compression that Francesca, who I think just walked in, is telling you about. So it gives you the basic building blocks to put something up on the web. So how does it go about doing this? So we all know NumPy arrays, basic properties, attributes of having an n-dimensional tensor. You want to know the shape, you want to know the type, and then you can kind of figure out how to write things to disk, right? But when those arrays go from being something small to being something that won't fit on your computer anymore, you need a solution. Obviously, you can start writing out multiple NPy arrays yourself, or you can have something that manages all of that for you. So that's what Zarr does. It basically is a protocol to take these big arrays, to chunk them up into various pieces, and to write each of those to disk separately with compression. That means when you go to read in the data, you can, if you want the stuff on the left, the yellow block, you only need to read in the chunks in purple that overlap that section. And if you do that right, then you're not reading in too much memory, and you can have fun with these huge petabyte scale arrays. Obviously, there's more to the protocol, but that's not what this talk is about. But at the end of the day, what this protocol does is it lets your client software, your browser or your Zarr runtime, figure out what chunks it wants to load and how, right? And just writing that down as a specification so that we as a community can stop worrying about it is kind of like a freeing thing that we can do. And then you can take these arrays and you can group multiple of them together and add some metadata. You can add annotations. So then at the end of the day, you have JSON files in green, and you have binary chunks, lots of them in purple, all in a format, in a directory that you can share either on the web or you can have them on your laptop. Various projects in the Python space got involved with this. We're very excited. We've seen a couple of different projects that use Zarr under the hoods. This Cube project, also Rechunker. So Dask and Xarray are the examples here where there are methods for reading and writing from Zarr. So that's great for the Python community. But really, with this specification, we can think about going, as I said earlier, out to other communities and making this something that's really, ubiquitous. So at the end of the day, the specification we're talking about here is quite simple. It's just a JSON document that tells you how to take an array and break it up into many parts, right? But the hope is if we do that well, and we get all the people at the table and we have a conversation with them, we can even have, say, in my case, microscopy vendors who are writing this from their instruments. That's kind of the end goal, is really to make this available everywhere. These are the languages that are supported currently. Most of these implementations have developed outside of the SciPy community. So we have the Zarr developers GitHub organization. Most of these live elsewhere. So many people getting on board because it really is something that's fairly straightforward to implement. So last slide from my side, just to put everything in a historical context. So the first line of code in Zarr was written in 2015. 2019, the inventor, Alistair Miles, presented at SciPy. That was kind of the growth phase of Zarr. And at that point, we started working on this V3 implementation, the next major implementation, the next major format. That's also about when I got involved. We got funding from CZI, so EOS S1 funding, joined NumFOCUS, moved from a model where Alistair was carrying everything to a steering council. Then COVID started, and it obviously got difficult, right? We were at the same time trying to move to a steering council model, develop a major new format, and develop an enhancement process all at the same time. Clearly, that is something you shouldn't be doing during COVID. And I think all of us with all of our projects can probably take a step back and pat ourselves on the shoulder and say, we survived it. So it's actually very good to be here and to talk about this. Coming out of COVID, we had another round of funding, so EOS S4, that helped us to pay Sankate to come on board as a permanent, or as a full-time community manager and really drive this enhancement process that he's going to tell you about. So with that, thanks for me. I'm very looking forward to talking to all of you. And I guess now the lights dim and the curtains open and Sankate comes up on, I was giving him clues the whole time. Come up on stage, please, because I'm about to hit the button. And enjoy.
Hello, everyone. Am I audible? Okay, cool. So I'm the community manager for the project. So by the way, thank you, Josh, for showing us the nice images and going through the inner workings of Zarr. And I'm the community manager, and I've been in this position since exactly 1.5 years. So I'm going to be focusing more on the community aspect of the project. Before I jump into my slides, may I know who in here like memes? Like only 2 people. Okay. Maybe I can convince you after the slides that I have like good memes to show you. And also if you could spot the origin for the memes, we may have like extra swags for you, like t-shirts or magnets. So yeah, look out for that. So there are like different elements to the community of the project, and when it comes to Zarr, I have actually what I've realized, there are like multiple elements which basically constitutes the community of our project. So first one is the open source software, which is actually how you use Zarr, and the specification. Then these are basically users and developers who use the project, and you have the contributors. And these are basically first-time contributors and long-time contributors and occasional contributors. And these are people who maintain the project, who have been in the project for a long time, and they take care of the project, and they have like push rights and all these things. And then you have the governance document and the council. So council plays a very important role in the major decisions of the project. So, and you start mixing all of them together, and yeah. So you might be thinking like why the professor is like afraid here. So this is actually not an element of the community, but it plays a vital role in growing the community and keeping it together, which is actually how easy it is to use Zarr and how hackable it is and language agnostic it is. So you can add new features to Zarr, and like it's very easy. So that's why the professor looks a little bit scared, because the community gets expanded really big when this happens. And there's a blast happens, and he's unconscious, and then he sees something cool, and yeah, now you have the project. So yeah, voila. So now you have the project. So as seen before, like we have like a big and diverse community, but this poses a challenge. Like you have people from so many domains like geospatial, genomics, data science, and bioimaging, and other domain, and climate scientists. So all these people have different feedback they want to include into Zarr, and basically want them in the specification. And all these feedback needs to be processed and basically included into the specification. So this slide basically shows that this is the Zarr, and he's trying to go, basically we are trying to move towards like standardizing the data formats. And this basically shows that we want everyone to use one format for storing the data, so that the vendors would not break, and there's like a trust among community. But you can see like there's a small, I don't know, like what do you call it? It's like a person or something which is holding it back, which is actually achieving the consensus. And this is actually very important thing when you're trying to develop something by keeping everyone on the same page. And this has been like one of the major things that I have faced when I joined the Zarr. And my job was to basically get everyone on the same page, and while moving the project forward and developing it. So yeah, I mean, which basically came down to like we needed a structured way to collect, like solicit the feedback and process it. So I mean, there are like the development for the Zarr v3, like the final version of the the latest version of the specification has been going on since last 4 years. And there are like lots of comments, lots of PRs, lots of issues. And this is like all distributed in GitHub. It's good to have like an active GitHub repository and lots of going on, but if you want to come to a conclusion, you need a central page to basically have those feedback in a single page. And for that, you need a process to basically collect all those feedback. And you need to document everything what has been happening and what is important for the decision to come around, which basically led to the creation of the ZEP process. So I'm sure people are familiar with like PEP, which is the Python Enhancement Proposal, and NEPS. So, which is, I stole the name from there, but I changed Z. So, which basically led to the creation of ZEPs. And what is ZEP? So ZEP is actually a mechanism how you can add changes to the specification of Zarr in a structured manner. And this on the screen you can see here is like ZEP 0, which lays out the purpose and processes. Like if you want to propose a change to the specification of the Zarr, specification is the main thing of Zarr, and on base of that you have different implementations in different languages. So, and how you can propose changes to it, it basically lays out all the rules and what you need to do that. And this was like one of the, I would say, one of the major thing I've done since I've joined Zarr, and important also. So a ZEP, basically there are, you can see there's like a flow chart on your screen, and you can see there are like different states the ZEP needs to go through before it gets accepted, or is it an active state. And I mean, the first and the foremost state is a draft, like everything gets submitted in a draft stage. And then you basically, the straightforward way is like it gets accepted and it's finalized and it's in the spec. But there are different ways as well, like it gets provisional. Provisional is kind of like an experimental stage where you try to test out your things, like if it's working for the community and project or not. And then it could get like rejected or accepted, and maybe it could get withdrawn. And on the like bottom right, you can see there's an active state. So active state is basically which lays out how the community should work. And this is like a everlasting ZEP process, which basically changes how the community and the governance process of the project should work. So this has been like really useful for adding changes in a systematic manner to the project and basically documenting everything and keeping everyone on the same page. This is gonna be like a small, like a personal journey of how I did it. So I'm gonna be like spending 2 slides on this if you, for everyone. So on the top left screen, you can see there's like a Venn diagram, and ZEP sits comfortably between like all 3 spheres. So why I did that? So I have been like using Python since 2014. And yeah, I've been familiar with PEPs and everything. So PEP was my first process which I was experienced, and I started reading PEP like completely, like from top to bottom. And then I realized PEP is something which is suitable, which is a very nice process, which is very well written out, and it lays out how you should do systematically in your project or into your not in a project, but in how you should do it systematically in a programming language. Then I started going towards the NEP. So NEP is actually stands for NumPy Enhancement Proposal, and this is basically based, like developed on top of PEP, which is suitable for an open source project. And there are some sections from PEP which are not in PEP, in NEP, because they doesn't apply to a project. They only apply for programming language. And on the bottom, you can see there's like STAC, which stands for Spatial Temporal Asset Catalog. And this is more of like a geospatial domain thing. And it's a specification, it's a way how you can develop a specification. But the most fascinating thing over here is like how they use Git and GitHub for their workflow. So they use like Git and GitHub like extensively for their workflow. And we wanted something like that. So like it was natural for me to go and start reading through this. And then I realized that ZEP is something which ZEP is something which should be intersection of all this. And I had some, like, I have been organizing, I don't know if you all have been to PyData conferences, but I have organized like 6 to 7 PyData conferences so far, and I've been in the program committee. So I know, like, I have been designing process to how to select CFPs and all that stuff. So I had like a little bit experience of how you can design process and everything. And the last and the foremost thing is, and the last and the most important thing is like understanding the needs of the community. So it almost took me like probably 3 or maybe more than, 3 or 4 months to finalize the ZEP process. And that was just me basically talking to the community back and forth, understanding how they want to do it and in which way how they want their feedback to be processed. So after like doing all of this, the ZEP was basically created, and I usually try to like write stuff on our blog post, and this is just like if you want to go, this is like a brain dump for like what I've thought and what I've been going through when I was writing the process. So if you are ever in a place you want to design a process for your project or your community or anything, maybe you should have a read, and maybe it'll help you. So yeah, that's all about the process. Let's move forward. So yeah, I've been talking about like ZEPs and everything. So how do we adopt it? So there is like, we moved from the steering council. So on the next slide, you can see there are like 3 people over there, which is actually the steering council of the project, which Josh has explained with Alistair Miles and everyone. So now we have moved to a different governing body, which is known as the Implementation Council. So Implementation Council basically consists of these representatives from different language implementations of Zarr. So this is basically really important because now we have moved to a model where the community gets to voice in, and they basically decide what changes that needs to be go into the project. And it has been like really good to see like people have been actively engaging with the project and trying to get So these people basically represent different domains, so they're like different changes and different feature requests from every domain, and we have been incorporating all of that. This is just like a slide to show like how you can adopt a zip. Like everybody needs to lay out a sword, like an imaginary sword, to adopt a zip. And we have the community and the implementation content, and ZSC stand for the steering council. I mean, steering council does play a role now, but they have to be on the same page with everyone to adopt a zip. So yeah, this slide basically shows that ZEP 0, which is the process, is actually still work in progress, and I mean, changes are welcome if you have read it, and if you have any suggestions. So we are still making changes to it and trying to make it perfect. Not perfect, but good enough for the project. Lastly, I would talk about a little bit about the evolution of the project. So you can see there's like a small slide which shows like the first illustration of the logo, and this is our, like on the second slide, on the second hand you can see the logo, which is like a slightly fine, but not the final logo, and it shows the evolution. So in the evolution umbrella, there are like multiple things which are under the evolution of the project, and I will be talking like a few of them. So the number of implementations has grown. So you can visit this link, and you can see there are like various languages over here who have implemented our specification. And you don't need to be like a Python user to use Zarr. You can use Zarr through any of the language. Adopters, like this was like really important. As you can see, there are some really cool groups and organizations over here, like NASA, Microsoft, who have been using Zarr to store their data. And some of them have been converting their archival data sets from different formats to NASA, which basically show there's like a trust among the vendors, and their data is not breaking, and people have been like trying to move way forward towards a format which is like cloud enabled and which is chunked. So if there are any vendors in the audience and they want to talk about like how they want to use Zarr, yeah, feel free to grab us. And yeah, I mean, we did an inaugural participation in these two programs, which is our Google Summer of Code and Outreachy last year. So it was really good to see that. And lastly, like, what did we learn after going like all of this? So yeah, so there are like creative ways how you can build and foster a community. Like in our case, it's like growing the number of implementation, participating in different programs, and all this stuff. And establishing trust is critical for standardization. Like being open, like I think the openness of the community and our project has basically given this like sense of trust to all these people who have been coming into our community and different organizations and groups and vendors. And it's critical if you want to move towards a goal of standardization. Like the third point is like it's difficult to get everyone on the same page. I mean, there's a saying like if you want to make everyone happy, you should be an ice cream seller. Yeah, I mean, that's right, but it's difficult but achievable, because it takes some time, it takes some work, but when you understand like how your community works and what are different mechanics and how you can operate them, you can bring them. And I think that's when it happens, that's really beautiful. And lastly, like we are all just humans trying to make something good for everyone. So people who contribute to the project, they do them on their volunteer time. So sometimes you would not get like a response in timely manner. So just try to be considerate to everyone. Try to be considerate on PRs and issue and reply with, with a little bit of warmness, and maybe they'll come back with something better. And I think that's it, yeah. So if you want to follow us, you're right.
Thank you. If you have a question, feel free to come on up. If you come on up to the microphone, that'd be great. The joke we used in the last session is we're chairs, we can't walk.
Hi, Chris Barker from NOAA. I'm curious about there's the different implementations of Zarr. Is that all kind of managed under one umbrella, or is everyone just doing their own thing?
Not all of them. Some of them are being hosted under their different organizations, different creative organizations, but we are basically trying to move towards a goal to host everyone under Zarr organization.
Right. Okay. So, and do you yet have kind of a testing framework that tests all the different implementations against each other?
No, and that's one of the things that's really missing. So it's actually in that second grad is to really make sure we have that TCK in place, because it's, I mean, there's a very small version of it, but it needs to be much more extensive. And just to give you one example of, an answer to the question, the Julia community was invited to come under the Zarr umbrella, and they chose, there was already a project, it's called Julia.io, and they felt it worked there. So in these projects that are an intersection between two communities, you have to make a decision, and it's thriving and it's doing well, and they have multiple contributors, so that was for them the right thing to do. So whatever's needed.
Thank you, everyone.